You have a question?
Yeah, so what if there was, zero water, like, trying to think of this scenario where it wouldn't be any water in the soil?
So if there's no water in the soil, let's say that these blue are air instead of water, right? So we've got void spaces, but we don't have any water.
Right.
The same mechanism is going to happen. You're going to have you're going to have this situation before the earthquake. You're going to have shaking during the earthquake, but instead of having fluid come up and separate the soil pieces, you're just going to have air.
Right.
So since air doesn't have any strength to keep soil apart from each other while it's being moved, you're not going to have this situation where the soil matrix takes on the shear strength of air, because you're still going to have those soil particles in contact with each other as they fall to the ground, as they get better organized. So the same mechanics are going to happen, but you're not going to have the danger of having things float, like, or of having things sink.
So like the underground utilities would pretty much stay where they are?
Yes.
Okay.
Yes.
But you would still have the possibility of a building collapsing because the soil would drop?
Not necessarily. You'd have the possibility of an unstable foundation from the elevation of the soil dropping. But if you have a deep enough foundation, it's not going to matter.
Right.
And a lot of times you'll see pictures actually of the elevation of the soil dropping. So for instance, you'll have a foundation that goes into the soil like this, right? And then you'll see that same foundation after liquefaction with an exposed area that shows the decrease in elevation.
Okay.
But there's no damage to the building because deep down, because there wasn't water there, this area did not act like water.
Yeah.
Sand just collapsed around the air particles and maintained its strength at depth.
Okay.